Just to go for having brush your teeth and have your bath and go for the breakfast. That's the optimum case. But in case if you are really hurry, sometimes it might be changed. But at the end of the day, if your solution is perfect, then most of the cases your what we call the output will be okay. As an example, you prepare and go to school. No one knows what happens behind the scene, whether you ate breakfast then go for brushing teeth or not. Got it? Yes. Ultimate solution. If the answer is okay, then the markers should consider what we call up to a certain level of okay, right? Because what I'm telling, sometimes your solution with the parts might be not exactly as the answer script or the marking scheme that you have. Don't worry, if your answer is okay, at the end of the day it gives a solution, you can get the marks. So don't get upset with these structural implementations. It might be here and there, it might be different. Don't worry about that, right? Okay. Sorry, yes, a question? No. No. Good, right. Pseudocode does not use symbols. We'll discuss pseudocodes later on, right? We'll discuss this pseudocode later on. But structured statements, there's no specific blah 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 things, but should use keywords as the flow diagrams, such as input output. Now we'll go for this flowchart structure. There are a set of symbols through flowchart. You should introduce to this each section. Every flowchart begins and ends with terminators. Right. We found the very first important thing. Start box at the beginning and end box at the end. Now, well, what you need to do, very first thing, you need to draw your starting, draw your stopping. Whether the question is extremely hard, whether the question you can't think even what to do, you very first thing start with the start box and go for the stop box. Now you know two things to complete. Without reading even the answer question, you can answer. You have to start with this one and end with this one. Got it? Yeah. Do you have a book at the moment with you? So a book which it's good to have to maintain a book. Then you can keep it with keep it until this course ends. Unless you might write in a paper, that paper is missing in next day, so you need to run here and there to find where my paper is. Yes. So, okay, found books. Found a book. Keep it with you forever for this class. Don't mix with the other classes. Uh, Whatever the place that you start, the beginning of the things, it might be something written, that's fine. Wherever you start, keep it with me and write whatever the stuff that I'm telling to you. You have to memorize all of these things. Okay. You should be a parrot. Okay. Okay, good. Right, start and end, stop. These are the notations for the start and stop boxes. So you will write them? Sorry? Should I write it down? Yeah, yeah. No, you should write, and next day you should memorize all of these things. Okay. Done. Done. Right. Next, most important point is arrows. Right. Whenever you are flow from a starting to ending place, there is an arrow. Which direction it moves? Which direction it moves? If it is goes this direction and comes, then it should be like this. If you are going upwards, you have to go like this, or else if there are some additional things, you can go in here, then comes to here. Likewise, you have to use arrows. Please don't just go for a line. There should be a head. It's a head. It's a must. So this is an arrow, right? This is an arrow. It's a must, right? It's a must to go for an arrow. Don't go for just line, because lines 0 marks. Yes. Arrows only considered for the marking. Clear? Yes. Right. Write down the third one, arrows. You just simply add an arrow and say state in your words. It's for the direction. That's all.
Which
Done.
uh, which done.
Done. Good. Right. We'll go for the next one then. Well, they are telling like this. Algorithms don't go straight away from start to stop. They also need input, output processing, decision, and loops. Right? So what they want input. We'll discuss what is this input. Input means something that you are enter to the system, add to the system. Output means something that gives by the system to you. System gives something for you. At the end of the day, it gives an output.
Yes.
Process, that is something that happens, an action. Simply it might be an addition, or it might be calculate the maximum number, minimum number, right? Something that some calculations or something is happening, right? So that's a process, something that is going. Data is changed at the end of the day. As an example, initially we have defined a variable called x to 1. The process is going to increase by 1 plus 1. Now the answer is x is 2, isn't it? X is
Yes.
2. So this is a process. This is a process. Starting one value, ending another value. That kind of a change. There is a change for data. It's a must.
Yes.
It's a must to have this end of this process to have. Decisions and loops. Decisions we'll discuss later on. We have a separate icon for that. And loops, we are iterating. Iteration is giving idea using these arrows, right? Using these arrows. Basically, decisions are telling like what you know already, true or false, yes or no.
Yes.
If it is this happens, I'll do this one. If not, I'll do that one. Right?
Yes.
That's a decision. Loop means it's an iteration. As an example, think you are enter your username and password to your Gmail account. I assume that you log out every time, right? I know personally you don't, but we'll
Yes.
assume it's a new system. We'll ignore Gmail. Gmail kind of a system, a new email system given by your organization. You entered username and password first time, incorrect. Second time, incorrect. Third time, again it's incorrect. Oh my God, you can't proceed furthermore. That's all. Your game over. Go out. It's an iteration. First time they allows you to enter username and password. Fine. Second time allows username and password. Fine. Third time allows username and password. No more options. You go out. There is a big difference in between a decision and a loop. Decision basically gives a direct solution. As an example, x is greater than 0. If it is greater than 0, you go to this direction or else you go to that direction. That's it. But once it comes to looping, you have multiple occurrences for the same thing. As an example, again, like username and password first time, occurrence 1, occurrence 2, third time, no more options. The condition falls similar to this one, you have to go out. So loops allows you to do multiple things, multiple occurrences, but decisions do not allow. It's just one, that's it, gone. Got it? Right. Few
Yes.
things to add to your book. What are the things that you need to add? Input processing and output loops. Write down these keywords: input, output, processing, decision, and loops. If you want, some of definitions are here. Don't write these
The
definitions as it is, because we are not computers, right? To store everything in our brain as it is. Write in your terms. What is input? What is output? What is processing? What is decision and computer? What is loops?
so what is like how does the processing box look like?
Sorry,
So when writing a flowchart, how does a processing box look?
I will discuss. We'll discuss. Don't worry.
Uh,
We'll discuss. We'll discuss about things.
So can you go back to the keywords? Okay.
Right. You just write down these key terms
Okay.
because all of a sudden sometimes they ask you some basic theory questions. You have input output. It's not all. There are more. What are the things? Remaining is processing, decisions, and loops.
Okay, sir.
Even if you just write processing, it's for that enough. But if you can write for decisions and loops, that's the ultra super case.
So I'll write down the definitions as well.
Yeah, definitions in your words, not the stuff in here. For a small aid is in here, but don't go for this aid. Just write in your words because we are not computers. We can't
Okay, sir.
remember anything as it is. Understand the structure, then write in your words. That's the
Okay.
word that you are writing in your examination.
Okay, sir. Okay, sir.
Done. Right.
Yes.
Now you have starting, stopping, and some of theoretical things. Input, output, process, decision, and loops. Well, nice. We'll go to the first topic, input and output, what they are telling. Algorithms often need, what is this? Uh, Output messages such as text to screen. Okay, something output. That's it. We understood it now. And therefore, to the user, they may also need taken from the user, for example, from the keyboard. It might be different kinds of input devices which you learn in your grade 7, if I'm not mistaken. Right, lot of input devices are there. We don't care. It's just data for us. It might be an image, it might be a text, anything. It's just 1 or 0. In our terms, that's it. Right, something is in to the system and something from the system to out. That's all for the input and output. You know the story. If you want the algorithm to output something to user, for example, a word, a sentence, something, then you need an output box. Well, the third term is an output box. How to draw an output box? Yes, you have to
Yeah.
draw for it.
Slanted.
Huh?
Like a slanted rectangle.
Yeah, it's a rhombus.
Numbers.
Rhombus kind of thing.
Even input looks like that.
Yeah, we'll go for.
Okay, sir.
Write down the third notation. Now you know output.
Okay, sir.
Right. You are drawing now faster.
Yes.
Good. After the output, hmm, put the text you want to display. If you want, oh, that's my. If you if you want to output hello world, you use this. Now, what you need to do, you need to kind of this kind of a big rhombus. So I don't know what kind of this, something like this, right? Parallelogram, parallelogram. I don't know. Something that you can give a nice name that you like, right? Whatever the things like this kind of a shape. Plus, what you need to do, you need to write a keyword output, and what is the output in here. Now, this is a fix. Output is a fix, but this one is dynamic. So according to the situation, it might be a value. As an example, output X,
Yes.
output your name, something, output your age, something. This is dynamic. So this is changing. It's not a fixed value. Hello world, they have given an example, but this term, uh, it's a key term. So you have to use as it is output. So now you have to do like this kind of a diagram, output, then whatever the stuff. Clear?
Yes.
Good. We go a bit further.
So like
Any questions up? Yeah, any questions up
if
to now?
the
Done.
output value is like declared in the pseudocode, then no need inverted no need the brackets like the inverted commas, right?
Pseudocode, if you have defined it in the pseudocode, still you need to write the stuff in here because
Oh,
pseudocode is a separate part.
no, I meant like the inverted commas.
Inverted commas we are adding to define it as a string.
Oh, okay.
Within double quotes means
So
it's a
like
string
it
output or
already
text.
declared the value as a string in the
Yeah.
pseudocode,
Then fine.
then no need the
Then,
inverted commas.
no, no, that
Okay.
that's fine. Then we know what is happening there.
Yes.
Got
Yes.
right. Updated the output a bit further. Now it's bit advanced. We'll go for further. Notice how words. Notice how the words being output are speech marks. Something that's fine because that you want actual words output. Hello could be a variable or command word. That's why I just told this is a string or a text. So if it is a text, we are adding within double quotes. If you want input data from the user into the algorithm, you use input box, which is very similar to the output box. Again, all you need to do is that's it. So by remembering one structure, you can go for two things, input and output, but make sure whenever if it is an output to add this output keyword plus whatever the stuff, whatever the output comes here. Input, you don't want to bother about that. You just write X or something, then fine.
So in
Right?
input, no need the inverted commas.
Usually we don't bother about that.
Okay.
Usually, but if you have time and if you are like very clear, you just go for input also. Then you can write for output stuff in here. You can go for output and input.
Mm.
Usually some of students using these colons or semicolons. It's up to you. It's not a major deal for have input and output. That's fine. Something all you need to do is go for this. This is the most important. This one is less important, but good to leave, right? Good to write and then you can tell I'm genius.
Okay.
Right. Usually you can see as an example input, whatever the stuff that you are inputting. If it is just my number, sometimes it might be clueless. What is this? So to avoid that one, usually we add input, add two dots in here. That makes sense. Then it's much easier for the audience or the people who are reading.
Okay.
Right. We know input and output. Good. Done. Any questions up to now?
Well,
All good.
yes.
All right, now we have a sample algorithmic implementation of flowchart for hello world. Now I think you can interpret this to me.
So that means like
Teach me what is this flowchart
so
is.
the algorithm starts, it outputs the text, the string hello world. Then you are supposed to input my number and the algorithm stops.
Good, very good. You understood the story. So we have the usual things, easy things. start and stop. One output and a one input. Now I
Yes.
think you can see the diagram in here, and the input is my number. This is known as a variable. Do you know what is this a variable?
Yes.
What is a variable?
So it's like the values you declared first in the
Okay,
source code.
good,
You declare.
good. Um, I'm not that much of advanced student, so how I'm remembering a variable is just an empty bucket. Variable is an empty bucket. What can I do? I can fill any amount of water according to my requirement. As an example, my number can be 20. Then after a while, I'm removing some amount. So it's 10. I'm adding some amount. Then it's 30. I'm removing something again. So it becomes 20 and so on and so forth. This is the amount of water in this bucket
Yes.
because I'm not that much of strong. So that's how I'm remembering. That's how a variable defines in my head. It's much easy, right?
Yes.
Ah, variable is a just empty bucket. And if we assign a value, then that's the amount of water that fill in that bucket.
Yes.
Good. As an example. Good. Right. So this is a simple flow chart. Quickly draw this one in your book.
So
Oh,
the flowchart.
yes, this flow chart as it is.
Done. Hmm. New.
Right. We'll do a question now.
Yes.
Question is, you need to take input. The variable name is X, right? Then output, thank you. Initially, you input a number. The variable name is X. Then output, thank you. Quickly draw and share it in the Telegram. Sorry, WhatsApp.
Okay. So input text, output. Thank you.
Yes,
Okay. So input X or text.
X, X. That is X.
Ah.
Share it in the WhatsApp.
Okay.
Always what you have done is to do is once you done the question, take a photo, quickly share it in WhatsApp.
Okay. So my the phone battery is at 1%. So I'll join from the laptop.
You're joined from the laptop. Huh?
So I'll join from the laptop. Sir. The phone battery is like 1%.
Oh,
So I'll join
you
from
have a
that.
cable. You have a cable to plug in.
Yes.
All right, we'll plug in the cable and do because unless it might be a very sleepy session after a while.
Okay. So it's I send it.
Right, good. Start input text, output. Thank you. Good. Well, if you want the perfectness, what you can do is starting and stop should be rounded corners. Have you noticed that one? See, it's rounded corners.
Okay.
It's rounded corners. So
So
go
will
for that
that
one.
mark is like
Yeah, for that, for now, that's fine. From next one onwards, please make sure to go for rounded corners.
okay.
Right, and make sure to stop the arrow uh, in the line. Don't go inside. As an example, output, I can see it goes to inside.
Yes.
Right. So now you are advanced level student.
Yes.
Right. So be careful whenever the things that you are writing and doing. Right. Good. Ours is good. No issues with that. But we'll go for perfect answer.
Okay.
Right. Once you have a variable, you can go for this one. That's fine. Now you know. All right. You might want output variable and some text. You can combine them by using ampersand like this, right? So what happens in here? You have output, two outputs basically. One output is a string output or a what we call a text. Here, my number is a text and my number. This is the variable. This is the text. So if we take the output in console or somewhere, you can see my number, right? My number. Then the value of this my number. It might be 12. If it is 12, it comes to here. If it is 14, it comes to here. My number and something. So and we are adding as a concatenation, right?
So
It's a
can I so instead of the n sign, can I write the end in capital?
well, usually we don't use that notation.
Okay.
Usually we don't. The best option is go for this one.
Okay.
So add a small note if you have a string and a variable. Usually for input and output both instances, we use this notation, a concatenation notation. This is the concatenation notation, ampersand. Combination of a string and a variable. Write a small note. It's an additional information. Always you need to think you are going for a level. It's not something that can take simple.
Yes. Done.
Done. Right. Uh, quick information related to pseudocode. What do you know related to a pseudocode?
So first you declare the values, then you use a suitable loop like for while or repeat and then you write the steps according to solve the problem, and you close the loop, and that's it.
Good. Basically, pseudocode is some instructions that we have written in plain English.
Yes.
That's it. That pseudocode consists of steps that we need to follow to get the proper output. That's all.
Yes.
That's all related to pseudocode. Pseudocodes and flowcharts are joined hand by hand. So whenever we have written something in pseudocode, that means we can write the exact same. We can draw the same thing in a flowchart, right? With the diagrammatic. This is the textual representation. This is the diagrammatic representation.
Yes.
Got it? Right. Same thing that you can go for output, input, write, print, and blah blah things. We'll discuss this pseudocode later on because one major issue for the students are some of students just follow pseudocodes in case, because I'm always trying for number of combinations. We are trying for the worst combination also. In case you are not writing pseudocode, you should read the instructions and draw flowchart as it is without writing pseudocode, because if we are writing pseudocode means it consumes some time. Some of students lack with this problem. Without pseudocode, they can't go for flowchart. So we'll directly jump into flowcharts without pseudocodes. Then we'll go for pseudocodes later, right? But just I have given some additional information for you. Right, something here, I think you can understand start and there is an output with double quotes. Input a variable is in here and we can see output with a string or a text plus a variable name. The variable name defines in here. Then this is a stop. Basically what happens in this scenario, starting a program, enter string, there is a string to string output slash enter your name, then there is a place to wait until the user input, then input name, that whatever the name, as an example Saluka, will added by the user, so it saves a variable called name. Now what we are going to do, we are going to output it welcome Saluka. That's all happens in this program. Got it? Clear?
Yes.
Clear?
Yes.
Good. Right. Questions? There are some questions. We'll go for questions. Work example. Well, since they have done a work example, we'll go for that. Convert the flowchart into pseudocode. Take each statement from within flowchart and write its own line, something in here. Right, that's a worked example, so we can understand it. Identify the symbol for starting stop in the flowchart. We are superb on that. Describe the stages. Yeah, we are superb on that also, so we don't want to bother a lot. Practical activity. Pseudocode. All right, kernel flowchart, no need. Algorithm needs to take word as input, output same word. All right, we'll go to this one. Question number 2, practical activity 4.2. This one. Quickly complete this question. Draw a flowchart for the algorithm.
So should I, when writing the input, should I say input hello or input word? Like the
You
string was
decide it. You decide it. It's a variable. That's it.
a variable. I sense.
Right. We'll see. Mm,
So like word is a variable.
all right. Good. Nice. Right. There is a joke. You can go for later. No need. Right. We'll go for processes. What are the processes? Usually it's a math uh, activity like here addition, subtraction, multiplication, division, power of modulus, integer division. Basically, modulus means I think you know the remaining how much it remains. As an example, if it is 10 divided by 3, speaking about this one, 3 3 into 3 it's 9, the remaining is 1. This is modulus. This is modulus. I think you know that. And integer division, if there are decimals, we don't care about the decimals. We just care about the integers.
Okay.
Clear? As an example, if you have numbers stored in the variable, you could change this. You might add something, subtract or something. Different types of processes are given here. Usually those are math operations, but not limited to math. As an example, string concatenation. My name is, and it is a string. Again, you're adding a string, someone or whatever. Right? My name is and something, that kind of a thing you can go for. So that's what I just want to emphasize here. It's not just math. Beyond maths, we have some additional work in processing. It's also a processing process. Right. How to add your process? It's just a rectangular box process.
All right.
Very easy. You know now starting, you know ending, you know input, you know output, you know processing.
Yes.
For the most part, we have covered the stuff that you need to know. Process box, usually adding some of information like this, or any other thing that you want to add. As an example, x plus 1 assigns to y, whatever. Right. X plus 1 assigns to 1, that kind of thing. Even okay, whatever the thing, it's just a processing. I think it's much easy for you. Just write that notation also, processing.
Okay.
Now you are Book should fill with the input, output, processing, and starting and ending.
Yes. Done.
Done. All right. Here in this process, numbers multiply. That we know that. Good. Oh, what is this? Assignment in process box. Could you please explain what is this?
It uh, gives you output message saying enter a number.
Good.
Then you enter number. You input number.
Good.
Then it outputs another message saying enter a second number.
Okay, good. Then it's
So does it
A.
continue?
Yeah, it's A. Then it goes to here,
Then
right?
you input num2.
Okay.
Then the answer is equal to num1 divided by num2.
Yeah, well, it's a process.
Yeah.
These are inputs. Have you not noted those things? These are
Yes.
outputs, inputs. This is the process.
Yes.
Rectangle. All right. Then
So then
it says a division.
you output the message by concatenating the string with the answer.
Good, good, good. This is the answer. It comes here. This is the string that we have defined, and this is the stop.
So,
Good. Now you
yes.
know the whole story.
Yes.
Right. Pseudocodes we'll do later on with these pseudos.
So pseudocode like the basic I'm familiar.
You're familiar with.
Yes.
That's much easier.
Yeah.
Right. What is this then?
So it outputs in message saying enter your age, and you input the age. Then a variable new age is assigned. So you add 50 to your normal age. That's assigned to a variable called new age. Then you output input in 50 years. You will be uh, new age by concatenating the two with the answer.
Superb.
Yes. Right.
Right. Some questions are there. What is a process? What action does operator? This one, I don't know. What is this one? Write a statement to multiply this one, this one. Describe the stages in this flowchart. Okay, we'll go for these questions quickly. Once you answered, you can share it with me.
So those four questions.
Yeah.
Yes. So write a statement to multiply 3 by 7. Should I write it in a process box?
Well, that's good.
Yes.
For the question 8, since you know this pseudocode, you could write pseudocode also. You have completed the answer. Oh, faster than expected. All right, not bad. Once it comes to marking, uh, they are paid for per paper, right? So it's your responsibility to make their life easier because they skim and give the marks. They don't go for all the steps. Your handwriting and clearness is very important to get a good mark.
Is it bad?
This is the uh, unreal truth. They don't go for all the XYZ things. They just quickly skim as soon as possible because per paper they paid.
Is the
So the
handwriting
ultimate, huh?
is it bad?
Yeah, handwriting is extremely bad. That's number one. Number two, it should be like proper, clear for the reader.
Okay. No, sir, it's like A4 like white sheet, so it's like harder to write.
Huh?
Uh, it's like A4 like no like single like don't have rules, no, so it's
Yeah,
harder.
yeah, yeah, that's fine. That's fine. No, my suggestion is once it comes to the examination time, write it clearly.
Okay.
Write it clearly. If you practice it now, then you will do the same thing in the examination.
Yes.
Right, somehow. Good. Appreciate that effort. Good. All good. We'll go for next. Some of practical activities. Right. We'll do later on. Decisions. Once it comes to these decisions, these are usually, I'm not telling always, it's usually a mathematical or a Boolean expression, evaluation of a Boolean value. That Boolean value means true or false. As an example, greater than, less than, greater than or equals, less than or equals, 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 not equals, or and. Somehow. Greater than, I think
Sir, for not
x
equal
is,
to yes.
sorry,
No, sir. No,
huh?
no, sir.
All right, then no need to wait for the decisions. Symbol for the decision is this kind of a nice diamond, right? So the diamond gives two edges for you, right? First arrow is telling yes. That means if the condition is true, you go this path. If the condition is false, you go this path. Clear? As an example, think we have defined x to 3, then my section, this section is x greater than 0, then I have to go for a diamond. Yes, in this case, yes. So you go for this direction. If it is -3, you go for this direction. This is yes, this is no, but it's not must. You can change the arms according to your requirement, but keep in mind it's much easy for this yes to one of left or right, then go for no for down. That makes sense and easy for the marking.
Okay.
Right, I think you know this one because you have shared it with me even at the beginning, or some of complicated question starting input data is age greater than or equals to 18. As an example, in this case, the user entered value as 2, then it's checking value is greater than or equals to 18. Now, since the user input value 2, it's not a true. Clear? It goes
Yes.
no branch and it gives output you are too young, then stops. In the other hand, if the user entered 22 as the age, now what happens in here? 22 is greater than 18. 22 is greater than 18, so it goes this direction. Yes, it gives an output. You are old enough, then it goes to here. Then what could be happen? Then it comes to here, guys. Right? Then it comes to here. It starts. Don't assume that it stops here. No, once you combine or you just pin to another arrow, it goes in that direction. That's all you need to understand. Any questions?
No, sir.
Good.
Sir, should
Easy.
I? Sir, no need to write that down.
Yeah, it's good to write. Neither we'll write.
The need?
Yeah,
Okay.
quickly draw. I think you know this stuff, but no need all. You just draw this one. This true and false. This one.
Done, sir.
All right, good. You have done it. Good. We'll go for next. Something here. Some pseudocode here. If else case end. No need worry. It's fine. All right. All right. Oh, what is this? What? Right. Right. An algorithm needs, we'll go for this one. An algorithm needs take two numbers and puts and largest draw flow chart for the diagram. They have given some steps. Good. Shall we draw?
Okay.
Okay, good. Can I stop it? All right, good. As for screen, it gives the answer. Bad. Perfect. Right. Quickly draw and share it with me.
So this step 1 to 5, then again step 1 to 5 is the are those separate questions?
Ask two inputs. Where's 1 to 5 again? Identify what steps need. No, 1 to 5 is enough. We
Okay.
start from here. Yeah. Again, it's just like identify what type of symbols. So we are directly drawing it.
Okay. So for to ask the user to input two numbers, can we say input num1 and num2? Or
Yeah, you decide it, that's fine.
okay. Also, can we write input random two.
Not yet. You no, not really. You need to write input number one, input number two.
Say in one box or like two separate boxes.
For me, it's fine for one single box, but we'll go for two boxes, right? In the
Okay.
examination, we'll let the reader to life easier.
Okay. So I sent.
Right, we'll see. We'll see whether you have answered properly. I need to start by identifying the steps required. Ask the user to input two numbers. Input I think you have written num2 both places, right?
So what's it?
Huh?
So what's it?
Num2 near the thing. It's like having
That's
num2 in both places, isn't it?
the num one and num two.
Num1 and num2. I can see it's like num2 in repeated repeated. So these are the biggest things, dear. Like students writing the answers, but once it comes to marking, they draw a big red circle and say incorrect.
Okay.
You know, you have written, I know, I can understand it's one and two, but once it comes to this marking, they just do the same thing. So don't do this kind of silly mistakes. It's like unwanted pressure that we are getting to our head. Right, good. Next, input two numbers. Good. Check if the first number is larger than the second one. Yes. Is yes. If yes, output the first number. If it is okay, good. No output. Okay, good. Right. Good then. All right. Nice. Good effort. Appreciate. I think now you are strong enough to handle many things. Some of questions are there, practical questions. No need. Loops. Right. Now, what's a loop? Loop is an iteration. Anything that you know? I think now you know something. Yes, loop is something.
It's like a repetition until it's like a repetition until a certain criteria is met.
Perfect. Perfect. Now, all you need to understand is what is this criteria, where this condition happens. Again, in here. When this is the place that you need to add the criteria. The logic should goes to here. The difference in this case is than just the situation that we just go through. In that case, it just goes down and right, and it goes to the end. That's the whole story, isn't it? But in this
Yes.
case, there is a big difference. The biggest difference here is it goes an iteration process. What is the iteration process? It comes here. Then if it is no, go to here, go to here, go to here, you go here and come here again. You go here, you go here, you go here and come again till the condition is true. You do the iteration process. So this is the iteration. There is no specific unique symbol that you need to memorize. All you need to understand is the logic.
Okay.
Okay, all you, sorry,
Okay.
right, all you need to understand is the logic. If you understood the logic, then the rest of the things are nothing. Then it goes to stop. So all you need to understand: start, stop, and there is input output, and there is a processing, and there is a condition. There is no specific symbol that we are defining for iterations, but it's the most complicated situation. Iterations are the loops are the most complex situation. Other things you can manage it because you can understand input output and stuff, but once it comes to iteration processes, you are getting into stuff where you are getting into stuff this logic and how can I iterate, where the iteration process is gone. So it comes with the practice. It comes in the practice. You have to practice, practice, and practice, and practice, practice again and again, again to complete this iteration flowchart. That's it's really hard to go. That's the complex situation. Up to now, it's easy, but once it comes to these iterations, it's not something easy. At a glance, sometimes you might unable to answer it. All right. Well, we
Yes.
have worked example 4.8. Ah, you if you want write something for the iterations, quickly write.
Uh, the knowledge
No
I
need.
understood.
You understood? Good. Right. Go for this one. Worked example.
Okay.
Is that hard?
So should we use like a for loop?
Yeah, it's a loop. See,
So
it's
should
repeat
we
10
say
times means all of a sudden you have to understand, all right, it's a loop.
so should we
Don't start
say
from here. Don't start from here. Start from here.
for index 1 to 10?
Oh, we are not using for.
So,
It's used in our pseudos, but this is a flowchart.
uh, so start, output, input mark, then input mark.
Okay,
After the motion. So then, where do you add the loop? Like,
that's right. All there is no place to specify. All you need to understand, where should I add this condition? What is the condition in this case? The condition is repeat 10 times. That means you have to start from a specific value, then it iterates once, twice, thrice, likewise 10 times you have to iterate it. Then once number 10 comes, it should goes out.
so
That's
can I
how.
say if index equals 10, then stop. If it's not equal to 10, then go back. Uh, Index equals index plus 1, then input
Yes.
mark, like
Yeah,
that.
that's perfect. Yeah, that's perfect.
So should I first say index is equal to 1 or 0 at first?
Yeah, at the beginning you have to initialize a value. It's your definition. You are telling initial value is 0 or 1. Then it iterates to greater than or equals to something. If it is equals, you can stop 10. If it is
Okay.
just greater than, you can go
So
for.
in what kind of box should I say index is equal to 0 at first?
It's an initialization, so it's kind of operation process.
Okay. So index is equal to 0, 1, 1, right?
Yeah, that's fine. You can start with 0 or 1. There is no restriction. It depends on you.
Okay. sense.
Life is really hard, isn't it? Run with now.
Yes.
Up to if else, all good. Once it comes to this looping, the iteration, it's
Is
like
wrong.
a nightmare. I'm correct, right?
Yes. Is it wrong or like
Huh?
the the answer wrong?
Yeah, it's bit. Usually the iterations are the most complicated things. Don't worry. We'll see what you have done. Index to one, then input. Your handwriting is really bad. What is this? Input mark. Okay. Output mark. Input mark total plus is index 10. Yes, average. Output average stop. No index. Index plus one. Okay, something that you have done. Appreciated. Good. Right. Though you have struggled, you have done a good job up to a good level. We'll see what they have done. Don't worry. This is very complicated. How genius thinks. We are not genius. Right. But don't worry. We should go near to the genius. We'll fix some of the things. Starting, good. They have initialized two things in here. All right. So the missing part for us is we have just go for index. We haven't defined two variables as it is. For a normal student, it's a bit hard to understand why we should go for two things. I know the story. So initializing first one is that's totally okay. Index is like a count that you have defined in here. So here in after we'll go for index to count. We'll change the variable name to count. All right. We'll keep it as count and whenever we have some math equation or something that like that, what we have to understand is there is a total something. So what we need to define is at the beginning we have to define that variable also.
Yes.
That's the first learned lesson from this activity. Next one is correct. Right. Next one is count. What they have done is they haven't asked to enter something. Instead of they just directly go to check the count is zero or not. At the moment, can you see my pointer?
Yes.
Can.
Yeah.
Can. Right. Total and count. Here the count is zero and it's checking count is zero or not. At the moment it's no. Hence they are telling to go for enter the mark. So the structure that we have defined and what they have defined is different. Don't get upset with that structural differences. Keep in mind, you can wake up, brush your teeth, bath,
It's like
then breakfast. Or else all of a sudden, wake up, breakfast, then bath, then brush your teeth.
that means there are like few like method marks.
Variations. Variations.
Okay.
Mm. Variations are there. That's obvious. It's not something weird. That's common.
Yeah.
Right, that's the common situation. Don't get upset with this structure. This is the genius answer. So your answer is okay, but we have to follow the genius to become a genius.
Yes.
All right, so we'll keep in mind this structure, how they solve this problem. That's why we are learning this solved questions. Right, is count, then no, then rest of the things it's much towards like the same like your answer, isn't it? So what you have done here is it's just go for output enter mark, then input mark, correct? Then they are telling total plus, that's good, count plus one. Well, we haven't defined that one. That means index upgrade that we haven't defined. We have defined after the logic, isn't it? After the logic, we have done it, but they have done like this. So keep in mind here in after to follow this structure. Then it counts goes to 1. Now initially it was 0. Now plus 1. Now the count value is 1. Now it comes to here again is count is 10, not really, still it's 2, it goes. So this is the iteration part. This is the iteration part. It's going every time until number 10 it goes to here. Now once it comes to number 10, no more additions are going. No more additions are going because it's not true. It is, sorry, no, it's false. It's true, it's not false. It comes here now, going for this average calculation. How they can define this average calculation? Because they have understood that at the beginning there is a total should be in here. In this case the total is defined in here, then calculated every iteration. Can you remember? See, every iteration the total was upgraded. Now that total was stored in here. This is the complicated thing, right? This is the complicated thing for a student to understand what the hell is going on, right? Don't worry. So this is the story that you need to understand. It goes iterated and this value is stored in here. I'll erase unless it might be very complicated now, right? Right. All you need to understand here, total was defined in here. After the calculation, that value stores in here. That value comes to here after the iteration was completed. Now further there's no iteration. There is an average is giving us the output, then it stops. So this is an example solution, a sample solution that you need to understand, right? Shall we upgrade our answer to align for this answer? Here in after, if you got this kind of a question, all you need to do is follow this structure. Most probably it's much towards more or less similar to this kind of a question that comes to you.
Quiz. I do a
There is
screen.
no too much changes that you need to do. The places that you have defined is different, but the logical flow is perfect, right? Logical flow is perfect.
That means
But
if I the one I wrote before, will I get some amount of marks for that?
yeah, definitely you will get around 90% of marks.
I
80
do
to 90. Yeah, 80 to 90% of marks you will get out of full marks.
I do a screenshot of this.
All right, you can take a screenshot, but you need to draw it again and again until your memory cells are not ready to learn. All right, so you have to do it. Now it's very hard, right? This is the hardest class that you have learned in your life.
One of
One of, all right. There are some more bad people like me. All right, good. Somehow, right.
what the,
So, sorry,
you was is it one of the hardest flowchart something?
sorry.
What was the question?
No, I'm telling you, this is the hardest class that you have ever studied, right?
No, no. So I had like, is it one of the hardest questions?
No. This is not a hard question. We have much more hard
Yeah.
questions to solve in future. Right, some of worked examples are here. Control loops, you can do it now. Okay, flowcharts, control loops. You are genius now. Not really. While loop. Ah, there's a worked example. Easy question. This one.
So is Cambridge like IT and computer science like similar?
Haha, that's why I told don't confuse with my materials.
No, sir, I'm saying like if it's similar, I can do both.
Huh?
If it's like similar, I can do both.
Yeah, it's much similar.
Okay,
It's like 80 to 90% similar.
okay.
You are planning to do that one also.
So I'll try
Yeah,
if it's similar. Yeah.
yeah, actually, whenever a computer science taken, the easiest thing is going for IT.
Okay.
Because it's much easy, much of theory content there. Computer science, we have a lot of logics and stuff. IT, you do have much theories, less logics.
Yes.
I don't think so you can change now.
No, not to change. As I do both.
Ah, Right. Then something.
So still doing. So like 2 minutes.
All right, all right, all right, all right. You can align to that answer, but this is not that much of complicated.
Okay.
I will upload the recording to YouTube. You can, I'll share the link, then you can download it, Ranmit. Basically, what we call this Teams access you don't have because it's organizational resource. So you are unable to access to the recordings. So what you can do is you can download from my YouTube channel, right?
Okay. So I sense. So I wrote from pencil. So don't
Sorry?
use. So I wrote it from pencil. Don't know whether it's clear.
Now, worry if it is wrong, who is going to kill you?
Yeah.
If it is wrong, that's fine. It's wrong. We'll
Answer.
fix it. Right. If it is wrong, now what is well what we have done here? Start count total. Ah, one myth. It's a must, right? Big letters and big diagrams in your final examination. It's a must run myth. It's very strongly advise you to, right? Unless this is like annoying. What is this? Really hard. Is total. Yes, output stop. No input number. Okay, okay. Now it is good effort. We'll see what they have done. Right. We'll see what they have done. Oh, this is the answer that they have given for us. Right, start. Good. We got 2 marks for that. Additionally, we have done total. Good. Is total greater than? Good. Well, it's asking greater than. You have written equals. Small mistake here.
So
No
no
output.
more than 100.
Sorry.
So it says no more than 100.
No more than 100. That means maximum 100. If it is 101, it should be terminated, right?
Yes.
Got it. It's a logic. You are iterating, like as an example now. Here we have defined 0. In any case, if it is 101, then it directly goes to here, right? So that's why we are asking for greater than 0. If it is greater than 0 only, you can go for something. If it is equal sign, then it's just checking whether it's 100 or not.
Yes.
Got it? Right. So you have done it. Good. Then it's enter number. You have written something. I can't read it. What is that? Right.
So
What
no
is?
need count.
Huh?
No need
Not it
count.
count. Not it count. Not it count.
Yes.
Right. Output. I don't know what is
So
this.
then sir, how to go to the next number without count?
Sorry.
If the total is less than 100,
Uh-huh.
then we go back to the loop.
Yes, we'll iterate it. We'll iterate. We'll
So
go for one. Yeah. We'll
then
iterate it and we'll see.
next number should be a different number. So how do we go to the next number without the count variable?
Well, what they are asking, uh, when the total is more than 100, output the total, right? So as an example, starting from a number, go it, add number, go it, and add, whatever. If it is
So
less
same
than
number,
100, until
the same number.
same number. Yeah, it's the same
Okay.
number, right? It's the same number. We'll see. It starts from here. It comes to this total. It's 0. We have defined manually. Then it's checking total is greater than 100. No. It comes to here. Enter a number. So we give an opportunity to user to enter a number and store in a variable called number. Then it comes to process. This is the number entered by the user. We'll assume the user entered number 1. And total at the moment is 0. 0 plus 1, the total is 1. 1, it goes to here and check total is 1. 100 is greater than 100. Not really. Not really. So it goes to here. Then asking the user to enter again. All right. Entered again another number. This time total is not 0, but
1.
1. Perfect. Now 1. The user entered numbers 100 this time. Now the total is 101. There is 1 plus 100. 101 is the total. It goes here. 101 is greater than 100. Of course, yes. It comes here. Output the total 101. Then stop the process.
Okay. So that means in any question, if like if they say no more than a number, we should take greater than that number.
Greater than,
Mm,
yes.
yes.
Got it?
Yes.
Clear?
Yeah.
Right. Now, basically, these are the structures of for loop. It starts from start end, then it goes to process, it goes input output, it goes logical. That means diamond. Then it goes iterations. We have number of iteration situations. It depends on the question that they are giving. Whatever the question that they are giving, scopes only for these structures. Now we need to practice. That's time for the practicing to solve these questions. How to practice, dear? We have to start from 2022, then go back as much as you can before next week.
Okay. So I'll
Don't
do
refer.
the
Sorry?
flowchart questions.
Huh? Sorry?
I'll, I'll do the flowchart questions from the papers and send you like through WhatsApp.
Definitely. What you
Okay.
need to do is you need to complete as much as if you can go for 2015, it's good. Up to that, you can solve all the questions. Make sure to take a screenshot of the question, then screenshot of your answer. Don't
Okay.
refer any book, any note, any question, any answer script, marking scheme, or anything. Write along,
Okay.
draw along, because in the examination, no one is around you.
Okay.
Right? No one is around you. You are the only one who is tackling everything. You are a Buddhist, Christian, or what?
Buddhist.
Buddhist. So no God, no one comes to you, right? No one
Yes.
comes back you and help you. You are the only person. You define your destiny, right?
Yes.
You have to define what I'm going to do. So struggle today, and the examination you will be a free person. You do it is much easier.
Yes.
I believe you can do almost all the questions. 2016 Sept one a bit complicated, if I'm not mistaken. Rest of the things I think it's much easier to answer now, right? So you can start from even 23 version, right?
The 23. Do you have the paper? The mayor? Mayor?
Sorry,
In 2023, the May one, do you have the paper?
May one I don't have actually. Do you have?
Then
No.
we don't like there is no computer science exam in January, right?
Yeah, no. That's why I told we can start 2022. Then it's much easy. All do have me. So we'll start from 22, then go back as much as you can. Okay? Happy?
Yes.
Great. We'll meet next week, Friday evening, sharp 6:30.
Uh, okay.
You do have some issue with Fridays?
So, do you have any other days like in the week days?
Any weekdays? What why Friday is hard for you?
A little bit
Little bit. You are going outside for a party every Friday evening.
the house.
Huh?
Like for the weekend, we are going to the other house.
Are your weekends you are going to another house? That means you are not living in Borlasgamu.
No, not Boulder. Angular and what?
Angulan and Vadh.
Yes.
All right, all right. Okay, then what we can do, I have one colleague, one student, we can change probably to Friday. Yeah, we'll go for then Tuesday,
Okay.
Tuesday evening,
Okay.
Tuesday 6:30.
Okay.
6:30 or 6, you are staying home or you are going for another place? Tuesday's home. Then we'll do around 4 o'clock, 4 to 6. Do you have classes or something at that time?
Like not at the moment.
Sorry,
Don't have any classes at the moment.
At the moment, you don't have. So we'll keep Tuesday 4 to 6. Huh? Confirmed?
Okay.
All right, Tanmay, then have a nice day. Do the questions and share the answers and everything that you are doing.
Okay.
Good luck. See you. Bye.
Thank
We'll
you.
meet and then Tuesday.
Thank you. Bye.
Bye.